Welcome all the learners. As we have discussed in previous video that what are the subsets of any set. We are continuing from that video. As you know that A and B are two sets. If all elements of first set are the elements of second set also, then we say first set is the subset of second set. So that we have set A, and its elements are 1, 2 and 3. Now firstly we will talk about how many subsets it may have. How many subsets it may have. So if we write here 1, 2 and 3 elements, then we say number of elements in set A is equal to 3. So the number of subsets of set A will be 2 raised to the power means 8. So if n is the cardinal number of any set, then total number of its subsets are given by 2 raised to the power n. 2 raised to the power n. So let us write what are its subsets. So if I am writing its subsets of A, you see phi is the subset of all the sets. Phi is the subset of all the sets, empty sets. Then 1, then 2, 3, 1, 2, 1, 3, 2, 3, and 1, 2, 3 combined. All these are its subsets. So let us count these as 1, 2, 3, 4, 5, 6, 7, 8. It has 8 number of subsets. So we can find out the number of subsets by the formula 2 raised to the power n. 2 raised to the power n will tell us the total number of subsets of this. Now, if we combine all these elements and make it a set, then it will become the power set of it. It will become the power set of it. So let us understand what is power set. Power set. And power set of a set is the collection of all the subsets. All the subsets of that set. Means power set of any set will be the collection of all the subsets of that set. So let A is equal to a set having the elements 1, 2 and 3, then its power set is denoted as PA will be equal to the collection of all the subsets. As we have written all the subsets of A here, so we will write here phi 1, 2, 3, 1, 2, 1, 3, 2, 3, and 1, 2. This is the power set. This is the power set of it. So here we will write number of elements in any power set is equal to 2 raised to the power n, where number of elements in set is equal. This will give us total number of subsets. Okay, so this is the parse. Set then parse. Let's take an example. With the help of that example, we will understand the difference between a set and subset. A set and subset. Okay. So let us have a problem. As we have any set containing the elements 1, 2 and a set 3, 4 then 5. Then 5. So here we will see some statements to be true or false, whether they are correct or incorrect. And the first statement is let 3, 4 is the subset of it. 1 is the subset of it. 1 belongs to it. 2, 3 belongs to it. 2, 3 belongs to it. We will discuss about these statements. So what do you understand by this? 3, 4 is the subset of it. 3, 4 is the subset of it. Is it true? Is it true? As we are seeing from the set, 3, 4 is the element of this set. It is the element of this set. So it is false. 3, 4 is not the subset. 3, 4 belongs to it. Belongs to it. So it is false. When will it become true? The true कब होगा? Whenever it will become a set. Whenever it will become a set. It will become true when we write 3, 4 like this. This is the subset. This is the subset. Similarly, one subset of A. As you are seeing from set A, 1 is the element of set A. So this is true, but this is false. But this is false. 1 belongs to A, 1 is not the subset. Here also 2, 3 belongs to A. Does 2, 3 belongs to A? No. 2 separate belongs to A. But with the combination of 3, it is not the element of A. So it is also false. So be very careful whenever we are dealing belongs and subset. Belongs and subset. Is 5 subset of A? Is 5 subset of A? Yes, it's true. Because we know 5 is the subset of all the sets. So it is true. Okay, this is the difference between belongs and subset. Okay, well, so now we are moving forward and now we are coming on intervals as the subset of real numbers. There are 3 types of intervals and it is very important to understand these intervals very carefully. Intervals as the subset of real numbers. So let A, B belongs to R. A and B, 2 elements belongs to R and age less than is less than. Then the set of real numbers, such that y is greater than a but less than. We are taking the real numbers greater than a but less than b. Then this is called an open. Called an open interval. And denoted as open interval A. So what will it tell? All the points between A and B, all the real numbers between A and B are the elements of this interval, but A and B are not included in this interval. So this is to be understood very clearly. All the real numbers between A and B are included in this interval, but endpoints means A and B are not. A and B are not. Except A and B, all the real numbers includes in this interval. So we may write it like this. If I am writing AB, then AB, sorry, this is the different symbol. I am going to tell you what is the difference between these two. AB is the open interval such that X belongs to R and X is greater than A but less than. It will contain all the real numbers between A and B. This is known as the open interval. Another interval is closed interval. Another interval is closed interval. What is that? Closed interval. If any interval is including the endpoints also, any interval which contains the endpoints also is called closed interval. The interval which contains endpoints also called closed interval. And denoted as closed interval. Denoted as closed interval. And we define closed interval AB is equals to X such that X is a real number that is greater equals to A but less equal. Here this point A and B both are included in this interval, so this interval is known as closed interval. By seeing these two intervals, you can understand there are some more intervals which we have closed open and open closed. Some more interval. as closed open. Closed open. So what it will say? It will be x such that x belongs to R and x is greater equals to A but less than B. Here A will be included but B will not include. Similarly, we may have AB, semi open closed, x such that x belongs to R and x is greater than A but less than B. This is another. As we have discussed here, the endpoints, whether endpoints are included or not included. So these may also be understood with the help of real number. That this is the real number. And it is point A, it is point B. If no point is included, then we denote these by empty circles. And we have the real numbers. We have the real numbers between A and B, like this. Then we will denote it A. Yeah, endpoints are not. So this is open interval. Another interval is like this. Here, endpoints are included. Endpoints are included. Let it is A. Let it is B. We are taking the real numbers between these two, and this will be denoted by closed interval. Another interval, closed open. When closed open will be like this. This is the included interval, and this is the empty interval. Let it is A. And it is B. We are taking the real numbers starting from A but less than B, then it will be AB. A will be included but B will not be included. Similarly, the fourth interval may also be denoted as, this is open and this is closed. That it is A, it is B. All the real numbers here will be denoted by this interval. So these are the intervals as the subset of real numbers. Wherever you will find open interval or closed interval, you will always understand that it is denoting the real numbers. It is denoting the real numbers. Well, so next topic we comes in as the Venn diagram. Is the Venn diagram. What are Venn diagram? Venn diagram are the diagram by which most of the relationship between these sets can be represented. Between these sets can be represented. So we are understanding what are the Venn diagrams. This is given by John Venn. John Venn. After his name, this diagram is named as Venn diagram. So, Venn diagram. So, what is Venn diagram? Venn diagram is the diagram which represents most of the relationship between the sets. As this type of diagrams in which one set is represented by rectangle and another sets are represented by circles. By circles. This rectangle denotes for universal. Rectangle usually denotes for universal set. As you know, what is universal set? Universal set is the biggest set in that context, or say basic set in that context. If we say the number system, the real number set is the universal set. Real number set is the universal set. Then universal set is denoted by U, like this, and it is represented by rectangle. And the small sets, these are the representation of the sets, and these are represented in the form of circles. This is the Venn diagram. And what does this Venn diagram tell? We will see later on, and we will understand its applicability. What is the applicability of Venn diagram? So we are starting the operations on sets, in which we will understand the importance of Venn diagram. So import operations on sets. Operations on sets. And the first operation is union. Union of two sets. Then let A and B be any two sets. A and B be any two sets. Then the union of set A and B is the set which contains all the elements of both sets. Let A and B be any two sets, then union of set A and B is the set which contains all the elements of both sets, but common elements being taken only once. Common elements being taken only once. This is denoted by symbol union. Universal and union have some difference. It is little more expanded. This is union. So what is A union B? A union B is equals to X such that X belongs to A or X belongs to, this is the element, either it is from A or it is from B, then it will come in the union of these two sets, A union B. Say for example, that we have A is the set containing the elements 1, 2 and 3, and B is another set containing the elements 2, 4, 6, then A union B will be, write the elements of A 1, 2 and 3. Now write those elements of set B which are not written till now. 2 we have written already, so we will repeat the 2 and we will write 4 and 6. 4 and 6. So this is A union B. Elements that we have written already, we will not repeat them. 1, 2, 3, then 1, 2, 3, 4, 6. This is the union of these two sets. Let us understand this one with the help of Venn diagram. With the help of Venn diagram. So let this is universal set, this is set A, and this is set. Then the elements which are either from A or from B means all the elements of set A and then all the elements of set B. Horizontal lines are representing set A and vertical lines are representing set B. Then this complete portion will denote A. This shaded portion will denote A union B. Either it is the element of A or it is the element of B, then it will be the element of A union B. Right? So this is the union of two sets. Let us see some of its properties. Union of two sets, its some properties. After it, we will take the second set. So, properties of union of two sets. Say more than two sets. Only union of sets. So, first property, A union B equals to B union. Means union of sets holds commutative property. Then A union B union C equals to A union B union C. Means associative property. The union of sets holds commutative property as well as associative property. As phi is the identity for union. If we take A union phi, then it is means phi is the identity for the sets of union. Then A union A. This is again A and it is known as idempotent law. Okay, this is the idempotent law. Then one more property, if we take the universal union A, then we get universal set. So these are some properties. These will be very helpful when we will deal the problems. Whether we find A union B or we find B union A, both the things are same. When three sets are given, either we find A union B then with union C, or firstly find the union with B and C, then take the union with A. Both the things are same. So these are the properties for the union of two sets. Next we come on intersection of sets. The next properties, next operation on sets is intersection of sets. Under the properties of sets, next property comes intersection. Intersection of sets. Intersection of sets. Let A and B are two sets, then A intersection B A intersection B, this is intersection, is a set which contains the common elements of A and B. A intersection B is the set which contains the common elements of A and B. So A intersection B is equals to X such that X belongs to A and X belongs to B. This is the intersection of these two sets. So with the help of Venn diagram, you may understand it like this, that this is set A and this is set B. Then the horizontal lines are representing for set A and vertical lines are representing to set B. Then the double shaded portion, the portion that is shaded by horizontal lines as well as vertical lines, this will denote A intersection. This will denote A intersection. Say for example, we write here A equals to 1, 2, 3 and 4 and set B is equals to 2, 3, x, y. Then A intersection B will contain the common elements. 2 and 3 are the elements of A as well as B also. So we will write A intersection B equals to 2. This is the intersection of two sets. So it has the properties just like union. Just like union. यूनियन की तरीके से इसकी भी प्रॉपर्टीज क्या कहता है, प्रॉपर्टीज ऑफ इंटरसेक्शन. Intersection of sets. Number 1, it holds commutative property. A intersection B equals to B intersection. A intersection B intersection C is